we're gonna go over some math. I want us to feel very comfortable with the idea of solving equations. If we get, if we're grounded in our algebra concepts, it's gonna make geometry easier, it's gonna make life a lot easier. And once you, I mean, at first you might feel uncomfortable, but as we get in the routine of doing it, you'll get more and more comfortable with the process. So with that being said, I'm gonna go through these problems with you. And I'm gonna actually, instead of using the computer screen, which is hard to write, I'm gonna use my own paper. I'm using 2 different cameras. So I'm gonna switch over the camera. Okay, so the very first part, when it comes to solving equations, that means one of the variables, you know, the letters that are in math now, that means you're gonna solve and say what X or B or G or whatever the variable is, what it is equal to. That's solving. And I've broken it down into 4 steps. So we worked on last week on combining like terms. I used the analogy of money. I said, like, if you have 3 $1 bills and 2 quarters and a dime, you know, you wouldn't tell somebody you had that. You would combine all those for a value of, you know, $3.60, because you would combine all your units together and values together to have something that's simplified. That's why. Because you don't want to tell everybody every single unit of money that you have. That would be stupid, kind of. It would take too long, depending on how much money you have as well. You would combine what's alike and simplify so that you have the same value, but it's going to be easier said. It's going to be easier to process. So before you start an algebra problem, you first do this, because the problem can look super, super long. But if you combine your like terms and simplify, then all of a sudden you're working with something a lot easier, okay? After you've made your equation simple, you wanna move your variable or variables, actually let me do that, variable, because sometimes you might have 2, or variables, to one side. It doesn't matter which side. Then after that, you wanna get the variable by itself. After you get the variable by itself and solve for it, you plug in the answers and check your problem. So let's do it. So I have 3x plus 2x plus 5 equals 20. All right, my step 1, combine and simplify. This equation can be a lot simpler. Instead of saying I have 3 x's and 2 x's, I can combine these because they're like terms. It's a number with an x in front of it. Instead of saying 3x plus 2x, I can combine these to make 5x. I drop down my plus 5 equals 20. Now in this problem, I only have a variable on one side. I don't have a variable over here. If I had 20 plus x, I would have to move the x over here, move my x's over on this side. But this is a convenient problem. My x's were already on one side of the equal sign. So move your variable, step 2, move your variables to one side. Well, that's done. Already moved, they're already on one side, they're on the left side. Now I'm on number 3, I have to get the variable by itself. Right now, the variable, which is x, is not by itself. It's being multiplied by 5, and it's having a 5 added to it. I don't want that. I want this and this to go away. The first thing you're gonna do is get rid of the plus 5. You're gonna get rid of your addition or subtraction. So we're gonna move this over here. We're gonna take it away. So that's gone. In algebra, remember this principle when solving equations, whatever you do to one side, you have to do to the other. Taking away 5 here, so I must take away 5 from the 20. Positive 5 minus 5, that's 0. So that cancels out, it's gone. My 5x drops down. My equals drops down. And I have 20 minus 5, that's gonna be 15. Again, the goal, get the variable by itself. Now I have 5x equals 15. 5x, that's multiplication. 5x means 5 times x. You undo multiplication with division. And the same can be said for the reverse. We'll do some problems where you have to undo division with multiplication. But you're gonna undo this multiplication with division. When you have this fraction line, this means divided by. And I'm gonna divide it by what's multiplying, the same value that's multiplying the variable. I'm gonna divide it by 5 because then this is gonna be 5 divided by 5, which equals 1. Well, 1x means 1 times x. And 1 times x is just x. Boom, it's by itself. So this is gonna end up being by itself. But remember, whatever you do to one side, you must do to the other. So if I divided this side by 5, I must divide this side by 5. Welcome, Marlon. Sign in, please. One x is just x, so it's by itself. 15 divided by 5. I know a lot of you guys might be comfortable with that, but if you're not comfortable with division, always remember that division is just the reverse of multiplication. 15 divided by 5 is the same as saying 5 times what? I'm not going to put an X. Times what? I'm going to put a question mark. 5 times what equals 15? 5 times what number equals 15? So 2, no. 5, that would be 10. 3, 5, 10, 15. Yes, it is. It would be 3. So 15 divided by 5. How do I know this is right? Well, the good thing about algebra is that you can always plug in your answer to the original equation. So if I go back to this equation, let me see, can I zoom this in? Let's see if I can zoom this in. Well, I guess not. Sorry, guys. I'm gonna see if I can make it closer. I guess I can't. All right, whatever. So if I go back, and what I'm saying is my claim is that x is equal to 3. So if I go back to this equation, I'm gonna plug in 3. Everywhere I see an x, I'm gonna put the 3. So 3, and remember 3x means 3 times x. So this is gonna be 3 times 3 plus 2 times 3 plus 5 equals 20. Okay, well, let's see. 3 times 3, that's gonna be 9. And then, so this is gonna end up being 9, I know that. And then 2 times 3 is gonna be 6 plus 5. 9 plus 6 is 15. 15 plus 5 is 20. Oh, well, does 20 equal 20? Yes, it does. So that's how I know that 3 is indeed the value of x. Because when I plug in 3 to the equation, I get a true statement. I end up getting 20 equals 20, and 20 indeed does equal 20. So let's do another one. Sometimes you might get something where you have to distribute. Ooh, scary. No, it's not. So in this problem, we have some parentheses. We have a little value on the outside. Same principle. I need to combine and simplify. My goal is to make this look easier to do. I want this to look a lot easier. And once you make it look easy, it's going to be easy. So for this, you have to do the foiling method, right? So even though you can't add a number with a number in a variable, you can multiply it. So I'm going to take this 4, I'm going to multiply it by what's inside. I'm going to multiply 4 by and 2x. And I'm going to do 4 times 2x. And I'm also going to do 4 times -3. I have to do both of those. 4 times, let's just think 4 times 2, right? 4 times 2 is 8. But we have to keep that x with it. So 4 times 2x is 8x. All right, 8x. 4 times -3. Now, when it comes to multiplication, remember the rules. If you multiply a positive number and a negative number, it's always going to be negative. Positive, if you multiply positive and negative, you get a negative number. So this is going to end up being negative. I know that. Now I have to just worry about 4 times 3. What's 4 times 3? 4, 8, 12. Or if you want to do 3 times 4, it'd be 3, 6, 9, 12. You just go through the multiples of the number to find it. 4 times 3 is 12. And because it's a positive and a negative being multiplied, this is going to be negative 12. Now, everything else just drops down. Plus 4 equals 8. We, at this point, are still in phase 1 because this can be simplified even more. We have 2 integers that have no variable. We have a negative 12 and a positive 4. We have a negative 12 and a positive 4. These are like terms. I can combine these. Okay, if I'm down $12, you know, I owe $12 to Jose, and I find $4, you know, that's positive. I'm gonna go up. I'm still gonna owe money though. If I owe $12, I need to find $12 so I can get back to 0, so I owe nothing. So I'm still gonna be in the negative. You know, I owe $12, I come up with 4. That means I'm gonna move up the scale. So that's why I had that number scale the other day where like, let's say this is 0 on the water, right on the brink. If I'm down here at 12, I'm down here at negative 12, but I find $4, I'm gonna move up. Negative 11, I only owe 11, only owe 10, only owe 9. Oh, if I find 4, I only owe 8. So negative 11, negative 10, negative 9, negative 8. And that makes sense, right? Because I went up 1, 2, 3, 4. I added 4. When you combine negative 12 and positive 4, you get negative 8. Then my value of 8x drops down, equals 8. Now, I've combined what I needed to combine. I've simplified the problem. This is what you need to understand. This value right here, this equation, is equal to this up here. This is no different than this and no different from this. Every single version of this equation are equal to each other. The only thing is that we've made it more and more simplified to the point where this is as simple as we can get it. This is as simple as we can get it. Now we can start going through our other steps to solve the equation. I want to get x by itself. Well, actually, I skipped, right? Move the variable to one side. But hey, we're pretty lucky because again, in this problem, there's only one variable and that variable is already on one side. So I don't have to move, anything. The variable's already here. So since it's already on the left, I have to get all this other crap over here. So again, 8x means 8 times x. And then it has a minus 8, subtracting it. Just like in this problem, I had to get rid of the plus 5. Get rid of your addition and subtraction first after you have the variable on one side. So this time we have a negative 8. In order for this negative 8 to go away, I have to add. The goal is to make it go away. And to make it go away, I have to turn it into a 0. So in this case, much like our number line over here, it's kind of funny because negative 8 is right here. In order to get from negative 8 to a 0, I'd have to add 8. Right? Negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. So I have to add 8. I'm going to add 8. What's the rule of algebra? Whatever you do to one side, you must do to the other. You must do the other. So if I add 8 on this side of the equal sign, this is the great divider. This is the fence, the equal sign, right? So I add 8 on this side, I add 8 on this side. This becomes 0, so it cancels out. It's gone. I'll draw my little line. My 8x drops down, equals, okay, 8 plus 8, I think we can all agree that's 16. The goal is still to get the variable by itself. We got rid of the 8, the minus 8. Now we got to get rid of this times 8, because 8x means 8 times 8 times x. This is multiplication. We undo multiplication with division. And I'm going to divide by the value that's multiplying the variable because it's going to be 1x, and 1x is just x. But whatever you do to one side, you do to the other. Since I divided by 8 on the left side, I have to divide this value by 8 as well. I end up getting x equals 16 divided by 8. That's not intimidating because we know that 16 divided by 8 is the same thing as saying 8 times what equals 16. And we know that's going to end up being 2. 16 divided by 8 is 2. Now, if you're going to go back, step 4, plug in and check. If you're going to go back and check your answer, I would recommend you go back and check it when it's already been simplified. Don't go plug in 2 over here. That's going to be more work for you. It's going to be easy for you to plug in your x at this point when it was super easy, when we simplified it. So that would look like this. I'll put it on the side. 8, instead of 8x, I'm saying x is 2, right? So 8 times 2 minus 8, right? Minus 8 equals 8. 8 times 2 is 16. 16 minus 8 equals 8. Well, it does. 16 minus 8 is 8. And 8, yes, it does equal 8. So I know that x does indeed equal 2. Does this make sense? Does this make a little bit more sense now? Or, and be honest, are you still lost? If you're still lost, or you're still like, I don't feel very comfortable with it, let me know, and that's fine. How's everybody handling it so far? You can put, let's see. Okay. Okay. All right, cool. Thank you, Jose, for the feedback, and Victor for the feedback. Okay. So I think this time, what I'm going to do is help, you guys are going to help me with it. You guys are going to help me with it a little bit more. So the first step is the most important step because it's going to make this look a lot, it's going to make it a lot easier to look at. Think of the steps in your head. The steps are really just to simplify the problem, make it look easy, get your variables to one side, and then get the variable by itself. Make the problem easy, get your variable to one side, get the variable by itself. Let's just start with that. Now, this is going to be a problem where you see we have variables on two different sides, the same variable on two different sides. So we're going to have to do some moving around, but that's okay. The very first thing we're going to do is look to see if we can combine anything. Combine and simplify. Combine and simplify. So, looking at this problem, is there anything that you can see? And always focus on just one side of the equal sign. Don't try to combine something from this side of the fence and this side of the fence, only on the same side. So let's look at this left side right here. -3 plus 5 plus 6g. Are there any like terms that can be combined on the left side? If so, let me know in the chat. What can we combine over here? That was fast. Yes, thank you, Victor. -3 is a regular integer, just like +5. These two can be combined. We combine it to make it simple. You're not going to say, oh, how much money do you have on you? Oh, well, oh, man, I have $5, and then yesterday I lost $3. You just say, I have $2 right now. So when you combine 5 and -3, you don't have to tell me all this. Just tell me that you have 2. You have +2. Okay? -3 plus 5 is the same as saying 5 minus 3. Now, this 6g, this can't be combined with 2. So it just drops down. Now, I have to look on this side, 11 and -3g. Can that be combined? I think this is where people get confused. For this portion, remember, when it comes to adding and subtracting, these cannot be combined. If this is multiplication, yes. But when it comes to adding and subtracting, 11 would have to have a g. It would have to have the same variable in order for you to combine it. So since it doesn't, 11 and -3g cannot be combined. So we just have to have that drop down. Okay, so this is as simple as we can make this equation. We made it as simple as we can. We made it as simple as we can. Our next problem, we know our focus. We want to find out what g is equal to. We have a g on this side, we have a g on this side. Even though I'm the only g in the room, if we're being honest. But anyway, so you have a choice. You can move g to the right and have your g, all your g's on this side. Or you could move your g's on the right to the left side. Either way, you're going to end up getting the correct answer if you follow the steps. But this is where I would urge you to think about preference. I think most people, especially most students, prefer to add than to subtract. We feel a lot more comfortable adding numbers than subtracting numbers. And if you know that you're that kind of person, we'll look at the situation. If you're going to have to move 6g to the right side, which is fine, if you did so, look, this is a positive 6g. So I'd have to use subtraction. And I would have to subtract 6g here and then do -3g minus 6g. You would end up getting -9g, just so you know. But a lot of students don't feel comfortable subtracting negative numbers. Well, make it easy on yourself. Instead of going and moving, taking 6g away and moving your g to this side, how about you do this? How about you add 3g so it goes away and then it goes to the left side, because then you're working with addition. In either case, you're eliminating it from one side. So you have a positive 6g, I would subtract 6g so that it's gone. Do the same thing on this side, because whatever you do to one side, you do to the other. In this case though, it's a -3g, I want it to go away. So I add 3g, because if you add positive 3g to -3g, it's 0. It's gone from this side. Here's your equal sign. Whatever you do to one side, we do to the other. Two, 6g plus 3g. These can be combined, right? Because they both are numbers with the same variable attached. This can be combined. 6g's in Compton and 3g's in South LA. It's gonna be plus 9 G equals, well, this is gone now, right? We eliminated it. 11. All right, now get the variable by itself. We got the variable on one side, on the left side. Now we got to get rid of this 2 and this 9. We're going to always work with the addition and subtracting first. So we got to get rid of this 2. It's a positive 2. So Jose, if we want to get rid of this 2, what do we do to it? It's a plus 2. How do we turn it into 0? If you got $2, how do you turn that $2 into no dollars? Okay, fine. So Jose, so if you have $2, how do you make it $0? I literally think that you have $2 in your hand and you wanted to have $0 in your hand. What would you do? Great. How would you waste it? Good answer. Yes, you would waste $2. What would you waste it on? What would you waste those $2 on? I don't know. Okay, fair enough. But the point is, when you say waste, I'm assuming that you mean like spend your money, right? Well, anytime you spend your money, you are, your money's being taken away. It's being subtracted. So that's the goal. Remember, I want to get this G by itself. So I want this to be gone. In order for this 2 to be gone, I have to take it away and subtract it. So you have $2. I want it to be gone. Then you're going to take away. And that's what subtraction is, right? So to get rid of the 2, I'm going to subtract the 2. But our rule is that whatever you do, whatever function or performance you do on one side of the equal sign, whatever I do on this side, I have to do it on this side. So if I took away the $2 here, I got to take away the $2 here from the 11. Jose wasted his money, so he has nothing. As far as his $2 go, it's gone. It's gone. We're just left with 9G on this side. Then on this side, we have 11 minus 2. Well, that's easy. That's going to be 9, right? You take away 2 from 11, it's going to be 9. Now, we have a very basic problem, very basic equation. 9G equals 9. The goal, we're still at getting the variable by itself. We did a good job. We got rid of the 2. Now all you have to do is get rid of the 9. 9G means 9 times G. This is multiplication. You undo multiplication with division. You're going to divide by same value on top so that it gets eliminated. 9 divided by 9 is 1. 1 times G is just G. Whatever you do to one side of the equal sign, you got to keep it fair. I got to do it to this side too. So in this problem, G equals 9 divided by 9. And 9 divided by 9 is just 1. Does everybody have a piece of paper? or something to write with. For the last part of first period, I want everybody to try this problem. 20 minus 7x equals 6x minus 6. Okay, maybe I should, hold on, let me see something quick. Do I have a book? This is a little bit better. All right. I'll give you a hint. Nothing's gonna be combined because 20 and negative 7x, these aren't like terms, they can't be combined. 6x and minus 6, those are not like terms, those won't be combined. So what you have to do is start to, since it's already simplified, you're gonna make a choice to move the variable to the right side or the left side. So once you guys get a little paper, a little pencil, I want you guys to try that independently. I'm gonna give you guys about, we'll do like 3 minutes, 3.5 minutes. Don't worry about your confidence. If you're not getting it still, that's my fault. I have to be a better teacher. And then we will find ways, everybody's at different levels or picks it up differently at a different pace. I will work with you. We will get it eventually. So don't feel discouraged if it's difficult at first. We all started math at different times. We're all in different levels. You know, if it makes you feel any better, I flunked math like 5 times. So, and now I'm your teacher. Hey-o. Wow. So, sorry, breaking news. I have to, I guess I don't have to, but I think you guys would care. And maybe we'll talk about this, because I guess it does tie into history. Breaking news. We strongly encourage the NFL Washington organization to rename their team in such a way that truly honors and respects the first Americans of this country, renaming the team Code Talkers to honor the Navajo Code Talkers and other tribal nations who used their sacred language to help win World War II, would set the team on a path to restoring the reputation and correcting the historical misrepresentation of indigenous people. So you guys have probably heard that there's been a lot of controversy over the NFL team's logo and name, the Washington Redskins. So the reason why that's controversial is because, for 2 reasons. One, Redskins, that was in reference to, you know, a race, right? A race of people. So, I mean, even though it seems harmless, I want you to think about that. That's kind of weird. I want you to think of, if you take a race of people and make it a commodity for a team, like for a mascot, that's kind of disrespectful to a lot of people. So like, what if you had like a team called like the Alabama Asians, and even if you had good intentions, it was like, yeah, we're the Alabama Asians, and you have you know, a mascot with a, you know, that looks like an Asian guy, and you know the stadium passes out little ninja stars and nunchucks toys and stuff like that, and you know, and even if it's like trying to be put a positive spin, we are the Alabama Asians because we are smart, disciplined, and determined and hardworking. It's still kind of demeaning because you are taking an actual race of people and generalizing it with stereotypes and then using it to as a commodity for a team. That'd be weird if you did that with any race. But Native Americans, they don't have that much of a voice because of history. We kind of, I'm not gonna say we, but the America, you know, wiped them out, put them on reservations. The other part that's really messed about it is historically the term redskin, back when Native Americans were being slaughtered, one of the ways that they like got a prize, like to like think of it like a trophy, is that they would cut off the scalps of the Native Americans after they killed them. They would collect them. Like, yeah, I got 8 of these redskins. I got 9 redskins. Oh wow, you killed nine Indians? Man, that guy, props. So it's like, damn, not only is your race being a commodity, as far in the form of a mascot, but the term redskin, that used to be like a racial slur back in the day. You know, after people collected redskins later on in society, like in the early 1900s, calling somebody a redskin was equivalent to calling somebody like maybe the N-word or something, or the B-word for Latinos and stuff like that. So it's so anyway, we kind of normalize it as a culture. It's like, oh well, that was the past, redskins, no, you know, get over it, kind of a thing. And like now, people in wake of you know, this social justice movement, they're like, hey, it's time we kind of change this. This is pretty ridiculous, and we got to do something about it. So I guess what they decided to do is change it to the Washington Code Talkers, because this was a group of Native Americans that were like revered and awesome in history. So I think if you take a group of people within a race or ethnicity, that's different. You know, like if you have the cowboys, or if you have, you know, the samurais, like if it's a specific group of people, the matadors, we've done that. But to make it an entire race, it's just kind of like, it's kind of weird. So anyway, back to math. I just thought that was cool. I'm gonna have to, I mean, I'm a Broncos fan anyway, but when I play Madden, that's gonna be crazy to just see the Washington Code Talkers and not the Washington Redskins anymore. All right, let's do this. So, let's see how you guys did. This problem is already simplified. So the only thing I have to do now is move the X to one side, the left or the right. If I want to do addition, because I like adding better, what I'm going to do is get rid of this negative 7x by adding 7x. If I wanted to, I could subtract 6x, make this 0, and then subtract 6x from negative 7x. I would end up getting negative 13x. But I don't know, a lot of people don't like working with those numbers, and I understand. So instead, what I'm going to do, I'm going to add 7x so that I can add it over here, because that's just easier to do, right? Oh, what's even worse? Being a Broncos fan? Who's your team, Jose? All right, so once I add the 7x, it's gonna be gone. My 20 drops down, my equals drops down. Now I'm left with 6 plus 7. The x's are the same, so it's going to be an x. We know that. But 6 plus 7, that's easy because 6 plus 6 is 12. Add one more, 13x. My minus 6 drops down. Oops, sorry. Eagles. We'll have to have a little talk. All right, so at this point, we have our x on our right side. Boom, we're done. We got our variable on one side. Then we have to get this variable by itself. We have to get the x by itself. We have a 6 subtracting it, and we have a 13 multiplying it. We have to get rid of the 6 and the negative 6 and 13. Always deal with the addition and subtraction first. This is a minus 6. I want to turn it to 0. I have to add 6. Whatever you do to one side, you do to the other. Down 6, come up 6, you're at 0, so this is gone. Your 13x drops down. 20 plus 6. Well, let's see it, Jose. 20 plus 6 is 26. Equals drops down. 13x means 13 times x. You undo multiplication with division. And I'm going to divide by the value multiplying the x so I can get 1. 1 times x is x. That's how you get it by itself. Whatever you do to one side, you do the other. And good job, Jose. What I like about this is that this is not a common multiple, you know? We don't work with 13s. We kind of stop at 12, right, with our times tables. So this is good because 26 divided by 13, what you probably recognize is that, oh, wait, 26 is twice as much as 13. So if this is half the value of 26, that means if I multiply 13 times what equals 26, I would have to double this value. You multiply it by 2, oh, what's 26? You multiply this by 2 to get this value, and indeed you're right, x equals 2. Good job, dude. Got it faster than I did. While talking about the Eagles, you know what's really funny? My high school was their own logos. So our team was the Marshall Eagles. I went to Marshall in Pasadena, but it's funny because our logo was the same eagle from the Eagles from the professional team. Just kind of funny. A lot of high schools do that. It's like, hey, isn't that the logo for the actual team? Come up with your own stuff. Anyway, I hope this made it a little bit easier. I know class ran a little bit longer, but I wanted to give you the opportunity to go through these problems because honestly, this type of problem solving is going to come in handy. It's useful to understand other facets of math, and I will work with you until we understand these basics pretty well. I also recorded this so that everything that we just did right now, you guys will have access to it and go back with, oh, how do I remember how to do this?